All right, you're welcome back again. This time we want to look at ANOSIM. ANOSIM. ANOSIM means analysis of similarity. Analysis of similarity. And when you have shape data of different types or of different category or different races or different species, you want to look at their similarity and dissimilarity. Are they dissimilar? For example, we have Africa, we have Asia, we have Europe. We want to look at this, want to test on their similarity, on their similarity significance to see how significant are they in similarity. Are they similar or dissimilar? So that's what we want to look at. So we want to use a ANOSIM to do the test. ANOSIM is actually a non-parametric test, all right? Non-parametric test in past to test for the similarity between two or more races or two or more species or two or more groups, all right, or based on their taxa. All right, so that's what we want to look at today. So if I use your normal shape data raw data, I'm talking about SY TPS file value, or you can also use your PC data. But the best way to use PC data, okay, which one you have gotten here, that's the best way to do it, okay. But you can also use your normal TPS data that you have generated, you have landmarked. You can import it as we have been doing before and use it, but you must include the groups, okay. You must include the groups here into the you must add it to it so that you can be able to differentiate. But now we are going to copy this to past and see how to test perform the ethical test on our data, because you must be able to perform an ethical test to show that this group are similar or dissimilar. Okay, using the criminal analysis is not enough. That's not a ethical test. Okay, you need to support it with a test. So let's see how we can do this in a pass quickly. All right, let's go to pass and I paste here. So we don't need this. We remove this gender. All right, so we change this one to group as usual. Okay, all right. So now we have our group here. Then we have our pieces data. I can select some PC and I can select all pieces. It doesn't matter. Okay, so I can say select all. I go to multivariate test one way ANOSIM. Okay, I'm doing one way ANOSIM because I have only one group of categorical data. Okay, if I have multiple, maybe I have two row, two column rather of a group data, maybe gender, and I can do for two-way ANOSIM. Okay, so now I click on one way ANOSIM here, and you see the results. And now this based on this 999 permutation, okay, this is using a mean ranking. All right, yes, it's using ranking to test based on the distance covered, which is distance measured, which is a Euclidean distance index. There are many indices that are here. You can use anyone you want, but by default is Euclidean distance by default. Okay, you can use Manhattan, you can use Chord, you can use Goa, and so many other. Actually, this particular one also is also very good. I have noticed the distance and Jakarta. So anyone, but the default one is Euclidean distance. Okay, that's a common and default one. So, but based on that distance measure, it gives you the rank. So, what is important here is R. P is not that too important because P shows that they are similar actually. So, because don't be confused with P value. Some because P is significant, doesn't mean that the P can be significant and still give you a very poor value. Now, this value we have here, 0.2, means it's very low. It means the similarity is very slow. Very low. What Haru is saying that the Haru ranges between -1 and +1, right? -1 and +1, that is Haru. Now the -1 means they are similar, where +1 means they are dissimilar. So the higher and positive the number of R, the better the similarity you have. Okay, so Now the similarity here is positive, at the same time it's low, 0.2, not up to 0.5, not talk less of going to turning to 1. So it means it shows that this value shows that they are similar, but the disparity is very small, right? That's what it means. They are similar, okay, but this particular value of R is so small. So that means you can't see much of the similarity, even though they are similar, but though it's not negative. So, and that is because we have in very small data. If you have a lot of data to test, a lot of observation to test this, you can be more, you can have more. The same way we saw in our scatter plot the other time, that we cannot see is differentiated much or separating much because of the small data we have. So the same way we have in auto our test here, I can see that it's small, but it shows that they are dissimilar. Okay, so that is how to perform ANOSIM for just for analysis of similarity. Okay, so don't forget, I repeat again, because this is where people make mistake. This R value, how to interpret R here. That's what I'm just doing now, because that's the major thing that they want to show that they are similar or not. This shows that they are similar, but they have a low, the similarity is very low. Okay, so because it's positive, and at the same time, at least it's not it's significant. So it means they have similarity. It means they are dissimilar. Now it means they are similar, but the similarity is low. Don't forget that they are dissimilar, but the similarity is very low. Okay, if it's negative, it means they are not dissimilar, which means they are similar. So that's what it means. So now take note. Now I want to know why are they dissimilar? Why are they dissimilar? Is it because of one particular category or not? So let's can check a pairwise now. This is a ad hoc test. Okay, maybe we can use maybe Boolean adjustments to see. All right. So here we have Africa, we have Asia, we have Europe. They are all so it's not based on uh one particular race. It's based on all the races are all giving significant value. So we can also look at the box plot of it. So this is between group. Okay, this is a group one, which is Africa. See here, group one, group two is Asia, group three is Europe. Based on our category, yeah, you can see our summary here. I mean our pairwise here, first, second, third. So and if you can also see here that the apart from Africa that is look a little bit uh, different from others. Asia and Europe, they are very close. You can see just small difference between Asia and Europe. They look sometimes they look alike, but Africa is different from them. Can you see the ranking distance? All right, so that's the ranking distance. So can you also click on the outlier, not outlier. So that is that for now. All right, so you want to can export the plot if you want. All right, change the size here. Guys, it's too small for you, and shoot the extension you want. So that is that for that under this. So you can we'll see later in the next class. So you can copy this and analyze in your data. Can be used for any kind of shape, whether leaf, whether bones, whether you can differentiate between the taxa. All right. Thank you so much. See you later.